Hey, so let's do today's independent work. It's the Desmos activity called Number Machines. I think this is a really good activity. It's supposed to help you sort of understand why the process for solving equations algebraically works backwards from like PEMDAS or GEMDAS the way it does. Sort of the point of this activity. So let's see if we can get it done. Let me pull my drawing tool out. We'll go with sort of dark red today. And the question on the screen says, this is the first page of the activity. We've built a machine that follows these instructions. Add 4, multiply by 2, and then subtract 3. If we put 10 into this machine, what will come out? Okay, so the 10 is like the input. And we want to figure out what number will be in this box here at the end that I would call the output from the machine. And so the number that we input is going to go through these 3 stages here. And once it's through those 3 stages, we'll have our output. So stage 1 says to add 4. So we're doing 10 plus 4, and that equals 14. Okay, so then that 14, I'm going to write up here where you can see better. This 14 goes to the second step where you're supposed to multiply by 2, and so that gets you 28. And then this 28 goes to the third stage where you're supposed to subtract by 3, so we do 28 minus 3, that gets us 25. So the output of this machine is 25. And so if we were to write this same number machine out as like instructions mathematically, what we did was 10 plus 4 times 2 minus 3. But notice that PEMDAS or GEMDAS would tell us to do the 2 times 4 first, which isn't how the machine worked, right? We did the 10 plus 4 first. And I might have misspoke there. The PEMDAS would tell us to do the 4 times 2 first if we were going to evaluate this expression. So in order to mimic what this machine just did, we would need to put the 10 plus 4 in parentheses. So 10 plus 4 first, then multiply by 2, then minus 3. And that got us 25. So let's put 25 up here. And we'll move on. Wait, what? Why did I mess up? Oh, it was going through the process and I didn't watch it. If you watch it, it shows you the numbers. Okay. Challenge number 1. Here's a machine that follows these instructions. Add 8. So it's only a 1-stage machine. It just, all it does is it takes a number and adds 8. Annika put a number into the machine and 13 came out. So this time we don't know the input number, but we know something about the output. This is kind of how equations are. You don't know what number is going into it, but you usually know something about what comes out. So our output, 13, it says 13 came out. And so this number here is going through the machine, 8 is being added to it, and then 13 comes out. Well, what we have here then essentially is an equation that says this: question mark plus 8 equals 13. Well, if we were doing it mathematically, we would use a variable instead of a question mark, right? Probably an x, that's what we tend to use a lot. So really what we have here is x plus 8 equals 13. Well, all we have to do is like reverse the machine, right? Go back. So we can figure out what number was the output by reversing the input. Instead of adding 8, we could just subtract 8 and we'll get the input. So 13 minus 8 equals 5. So I think the input was 5, right? If we were to put 5 into the machine and it added 8, we would get 13. So we reversed it. We did 13 minus 8 to get back to that input number of 5. And so when we solve equations algebraically, we would start with an equation that looks like this: x plus 8 equals 13. And we would say, okay, this machine, right? I'm calling this part of the equation right here a machine. It's like a machine that's taking my x and adding 8. Well, I don't want to know what x plus 8 is. I just care what x by itself is. So let me undo the machine. Let me put it in reverse and subtract 8. But if I subtract 8 over here next to my x, in order to keep the equation fair, I got to subtract from the other side too to keep it balanced. And so we get x equals 5. Let's submit it. We'll watch it go through the machine. We got it. All right, so challenge number 2 is another machine where we know the output, but we don't know the input. And so we're going to have to put this machine in reverse to figure out what number went into it. Right, in the question, or in the instructions, whatever you want to say, it tells us that 40 came out of the machine. So our output over here is 40. Some number is going in, being multiplied by 3, and then subtracted by 2, and we get 40. So, well, you know, this middle part here is kind of easy, right? Because the last step of the machine says some number is going to go into this part, this stage, and be subtracted by 2 and get 40, right? So it kind of tells us, I think 42 has to go right here, right? Because 42 subtract 2 will get us to 40. So that helps us a lot, because that means whatever number that goes here, I'm going to start calling this x. Our unknown input, that's our x. Something times 3, it's got to get us that 42 that we need, right? Well, let's just put this whole machine in reverse and see what happens. If I start with 40, and the machine would operate this way, it would multiply by 3, subtract by 2, get me 40. Let me undo that. Let me put the machine in reverse and kind of reverse the steps so I can get back to the number I started from. So I'm going to go up here. To get from 40 to that 42, I need to add 2, right? So I'm doing the opposite of what the machine did. The machine subtracted 2, so for me to undo it, I'm adding 2. And so I'm going to do the same thing to this stage. The machine took some number and multiplied it by 3 in order to create that 42. So let me undo it. I'm going to divide by 3. That equals 14. So I'm pretty sure that this unknown x input was 14. Now let's look at how that's done algebraically. The machine is multiplying our unknown number by 3. We write that as 3x. And then it's subtracting 2. And the output was 40. So this is the algebraic equation that represents our machine. And the steps we did to work backwards, well, first we added 2. And that's exactly what I would do if I was solving this equation. I see minus 2 here. I want to do the inverse operation of that. I want to say, let's add 2. But if I do it to one side, I have to do it to the other. And what happens here is we have minus 2 and plus 2, or you can think of it as negative 2 and positive 2. Those things mean basically the same thing. Well, when you combine those, they make a 0. So the new equation you arrive at is 3x plus 0 equals 42. I didn't bother to write the plus 0. It's pointless, right? So what this says is 3 times our unknown number equals 42. That's exactly where we were at this part of the number machine, right? We knew that it had to be a 42 that came out of that first step, which is multiplying by 3. And so in order to undo it, we divided by 3 to get our input number. And that's exactly what you should do here in this equation too. 3 times our unknown number is 42. I want to divide that 3 away, but I got to do it to both sides. And what happens is this 3 times x and 3 divided by, or 3 times x, but then divided by 3. The 3 on top and the 3 on bottom, they sort of make like a fraction. They divide each other and they create a 1. And so what you're left with is 1x. So I could write an invisible 1 next to that x, but I don't like to do that. It's just x, 1x. Divided by 3 equals 14. So I'm pretty sure 14 is going to be our answer on this one. We got it. All right. Next one. Callan is about to put a number into this machine. This machine adds 13 and then divides by 2. Then he will tell you what comes out. How will you figure out the number he put in? Okay, so this one's not asking us to solve anything because they didn't give us an input number or an output number. What they're saying is, what they're asking you is like, have you figured out the process? Have you figured out how this works? Well, the general process is whatever the machine is doing, you do the opposite thing and in backwards order, right? You start from the last step of the machine, which is dividing by 2, right? Let's say we had this is another unknown number here. So I'll use y because I'm using x for this one over here. So we got another unknown number here. But if we did know what number that was, we would first put it through this stage of the machine. But instead of dividing by 2, we would multiply by 2 because we're always trying to do the opposite of what the machine did, right? So we can work backwards. And then after we multiply by 2, we would take that number and we would put it through the first part of the machine again, but we would do the opposite. See, the machine added 13, so we would subtract 13. And if we did those two things, we would be able to figure out what that input number is. So let's write essentially a set of instructions. Our instructions should say, first, take the output, right? That's what I'm calling this number that I wrote here with a y, like the number that comes out of the end of the machine, and multiply by 2, right? That's the second stage of the machine, but the opposite. Then take that number, whatever we would get after we multiply by 2, and subtract 13. Because now we're doing the first stage of the machine, but the opposite. Instead of adding 13, we're subtracting 13. So that's the whole process here. Like whatever you get on the output, you just do the machine in reverse order and you do the opposite of everything you see. And that's exactly how solving algebraic equations work. We do what all the operations we see, we do them in reverse order, meaning reverse PEMDAS or GEMDAS order, and we do the opposite of whatever it is. If it's division, we do multiplication. If it's addition, we do subtraction. If it's subtraction, we do addition, etc. All right, so here's Callan's machine again. This time they give us the output number again. So it's kind of just another one of, it's literally the one we just wrote instructions for, right? But now they gave us the number, they gave us 15. And so we wrote instructions on the previous screen on exactly how to solve this one. We're gonna take the number here and multiply it by 2. So we're gonna do 15 times 2, that equals 30. And then we're gonna take that number and we're gonna subtract 13, right? The opposite of adding, so 30 minus 13 equals 17. And so algebraically, what we just did is we had some unknown input number, right? And it was being added 13, right? I'm going in order of the machine now in order to write the equation. And then it was being divided by 2. So the whole thing divided by 2. I put the x and the 13 all on top of a fraction bar so that that sort of tells someone who's looking at it, oh, do the x plus 13 first, then divide by 2. And that's supposed to equal 15. And so in order to solve this, if I was going to solve it algebraically, I would see this division by 2 happening here. And I would say, I want to do the opposite of that, get rid of it. So I would multiply by 2. I write that by putting a little 2 in parentheses over here. But I do the same thing over here. I got to multiply this by 2. And so what happens is it's like you have 2 on top of a fraction here and 2 on bottom of a fraction. 2 over 2, they make a 1. So they essentially cancel out, go away, as mathematicians like to say. What you wind up with is 1 times x plus 13. But nobody ever writes that 1. You would just wind up with x plus 13 equals 15 times 2 is 30. And so now the only thing that's happening to my x is it's just being added by 13. I want to get rid of that, so I subtract 13 from both sides. The plus 13 and the minus 13, they combine and make a 0, so they go away. And all I have left is x equals 17. All right, so what I'd like you to do is make your own challenge here where you get to pick what the machine will do. So I'll show you how to make one and then you make one. All right, so you can have 1, 2, 3, or 4 steps in your machine. I'll make a 2-stepper. We don't need to get too crazy with it. And so what you do is you drag the dot to be what operation you want your machine to do. So I'm going to have my machine multiply and then subtract. And in the first stage, it's going to multiply my number by 6, and then it's going to subtract 4. Okay, and then it says choose an integer that's a whole number, but it can be positive or negative. And this is the input number. And then what's going to happen is it's going to give this challenge to other students, but it won't give them the input number. It'll give them the output number, and they're going to have to work backwards to figure out what your input number was. Choose someone else's challenge and do one. You can do as many as you want, but you need to do at least one, please. If you're in my class, I don't know what Mr. Wong told you if you're in his class. So let's see here. What number should I put in? What do I want to have multiply by 6 and subtract by 4? How about -3? So let's see here. That should get -3 times 6 is -18. Then you subtract 4, you get -22. Okay, so now what'll happen is somebody else will see -22, and they're going to have to add 4 and then divide by 6, and they'll get my -3 that I put in. All right. That's it. See ya.